All right, so my students, my algebra 2 students, they are still working on exponential functions. As in the last videos, the exponential functions that they have been working on have been in the form y equals a times b to the x, or written y equals a b to the x. All right, so I transitioned into this one because this one builds better into the next form, which this video is about, that students are going to be receiving their exponential functions in. All right, so the next form is going to be, actually before that, let's talk about what each of these variables mean again. Grab a different color. Y was the total amount. A was the initial amount. B was growth / decay factor, and then this guy was time, for the most part, usually time. All right, now we're going to move into something that is always in time, and what that is, and I'll go from this one, is y is going to become, oh my gosh, I gotta get rid of these two. Y is going to become a. We got p 1 plus minus r t. So y becomes a. A little a is going to become p. X is now always time, no matter what. We're talking about time. B has changed a lot. Now B is the only one that has actually changed. This is still total amount. Still total amount. This is still initial amount. It's just called something a little bit different now. Now it's going to be called, or can be called, principal. All right, still initial amount. Just another way is it's a principal. It's what you're putting down on something. It's what you're starting with, investing with. Still the initial amount. Principal if we're talking about money. Total amount, initial amount. This, we'll talk about that next. And X, in this case T, is still time. Total amount, initial amount, time. The only thing that's changed is this. B was changed, and B initially was growth and decay factor. Factor didn't show what percent is this thing increasing at. And I think in one of the videos I did, hinted at how my students were eventually going to find rate, the percent. Is this growing 200%? Is it decaying by 25% every time? What is it growing and decaying by? Not what is it multiplying by mathematically, but what is it actually decaying by? How much do I have left over? How much more do I have every single time in a rate? So, let's erase some stuff. Let's get rid of this. Don't care about this anymore. I mean, do still care about it, but not for the rest of this video. So, if I have A equals P 1 plus minus R, this all right, this is B, but it's written in a different form, so B is equal to 1 plus or minus R. These two things you can change between them. You can change back and forth. All right, if I have this and I want to know what the growth or decay rate, because this, let me get different. This is factor. This over here is rate. Rate factor. This little 1 represents 100%. And hopefully that makes sense, because when you start out with something, you start with 100%, right? Your initial amount. If I'm going to go invest or take out a loan, take out a college loan, and that loan is $20,000, then I start at $20,000, and it starts to usually grow from there if you're not paying it off, right? Because it's got an interest rate, and the interest rate adds money onto it over time. But you start at that and you grow a percent, maybe 3% or 4.39%, whatever your percentage rate deal is on it. Or let's say you went clothes shopping online and there's a 40% off deal. Well, that's decay. That's a decay, right? You're taking away 40%. So this just highlights what is it actually losing, what is it actually gaining as a percent based on what's it starting with. It starts with 100% and it's decaying this much. Makes a whole lot more sense when we involve numbers. So what we're looking for is we want to find the rate. So the highlight of this, what is the rate? All right, so if I have an equation, A over time equals, let's start with, I don't know, $500, 500 something, 1 minus 0.3. So what is the rate? I look through these numbers. Okay, well that's P. That's just 1. That's R. Now notice, I do want to highlight this plus or minus is or. It's not, you're not going to have plus or minus in there all the time. It's either a minus or it's a plus. If it's minus, it's decay. If it's plus, it's growth, right? You're taking away how much. So this piece right here is R. So R equals growth or decay. It's minus. So decay rate of, now this is where some students really get tricked up because they're not used to converting decimals to percent. They learned it a long time before, but they haven't used it too often. 0.3 is 30%. All right, and I'll put up here, I made notes for my students, but if you don't know how to convert a percent or a decimal to a percent, what you do is 100 times the decimal equals the percent. All right, 100 times the decimal equals the percent. So if I do 0.3 times 100, I get 30, so 30%. And it's decay because it's minus. Decay minus 30% because that's 0.3. Let's do another one. Let's say A of T equals, say you're gonna, that's too little over the bank account. Let's say you finally saved that $500. Let's do 500 again. And you're gonna open your first bank account. You're gonna open your first savings account. And the person there is gonna give you a savings rate of, let's do 2%. That might be too high if it's your first savings account, might be too low, depends on how lucky you are. So 2%, probably too high. But my rate, and I kind of already set it out because I was trying to make the problem, my rate is a growth, because it's plus, I'm gaining money, right? That's the idea of a savings bank, is if I leave it in there, I'm gaining money. Savings, so growth of 2%. All right, this plus 0.02 is plus 2%. I'm growing 2%. All right, and in this case, it'd be 2% every year. This is where it starts to get trickier. All right, so I gave you some easy ones where I gave you 1 plus R or 1 minus R, so you knew what R was. What if I give you it back in this form? So what if I give you, let's say, 50, let's do 1.5. That's that. I don't know what R is. I have an issue. I need to answer with the rate, but I don't know what the rate is. I know what B is. I don't know what R is. So I have to find that, and I can find that because I know that B equals 1 plus or minus R. So I just rewrite this. Now you have to decide, is it plus or minus? You know it's got to be 1. That 1 is always there. Now, if I need to get to 1.5, do I add or take away? Hopefully you add. It's bigger. I need to add something. Well, what do I add to 1 to get 1.5? Gotta do my waiting time. Usually a student would just blurt it out immediately. 0.5? All right, hopefully that makes sense, right? 1 plus 0.5 is 1.5, so I change this. I change this to be 1 plus R. So now I know what R is. This is R. So now I can answer the question, and the question was, what is the rate? Well, the rate is, so R equals a growth rate of 50%. 0.5 to half, 50%. All right, growth rate of 50%. Let's do another one. All right, get rid of that. Start with 2000. Let's say this is like do population. Let's say you have 2,000 polar bears, because we all know polar bears going extinct, unfortunately. All right, let's say you have 2,000 of them. Hopefully there's more than 2,000. Let's say you got 2,000. So they're decaying, so that needs to be less than 1, right? Your factor needs to be less than 1. So let's do 0.77. All right, if I have a decay factor, that means that this will get smaller every time, because my decay factor is between 0 and 1. But I don't want the decay factor. Again, I don't want the factor right now. I want to know what the rate is. So I need to change this factor to a rate. So I have B right now. I need to find R. So 2,000 times 1 minus, all right, because it's less than 1, I need to subtract off. I am decaying. Polar bears are going extinct, unfortunately. We're losing the amount of population of polar bears. So what do I subtract from 1 to get 0.77? Well, you could on your calculator right now just find the difference, do 1 minus 0.77 and find out what the difference is, and you would get 0.23. All right, so now I have it in the correct form that I need it to be in, which is 1 minus r, so I now know what my rate is. So r equals a decay rate of 23%. That's where I'm going to leave off of this video. My students aren't going to be solving anything yet. They just have to identify R and whether it's a growth rate or a decay rate and what it is as a percent. Soon to come though, they'll be solving some story problems and applications with, bless me,